Okay, this is the first revision recording of the day. It is currently 8:48 p.m., which is a little bit late. Well, it's very late to start, but I have some important things to do first. Um, so I'm going to do them, and then I'm going to uh, I'm going to move on. So the things I have to do is find references for a um, document I'm doing for chemistry. So I'll record a little bit of that, but that'll basically just be a short little intro bit, kind of, just to get that done and uploaded, and then I'll move on to the revision. I'll give myself until midnight, so if it's, almost 9 o'clock now, that gives me 3 hours, or 3 hours and 10 minutes roughly, to get everything I need done, which should be enough time um, yeah, to, to get everything done, so I'm not hugely worried about time. Plus, I can go later if I need to. Okay, I'm gonna go get some water, and then I'm gonna start on the other, on my referencing, and then I'll get onto this. Okay, so I've got up my document here. Essentially, all I think I have to do is go through these risk assessment things, check I got the correct stuff. So, for example, this is wrong. This should be inside the. Uh, what's happened here? So this is correct. This one has been messed up a bit. So uh, insert row below, and then this should go here, and this should go here. This can now disappear, and so can this. Why is this here? Seems good now. And then I have to also include the 1 mol dm cubed aqueous here. Okay. This is glassware. This is glassware. Um, okay, next one. Uh, nitric acid. Like so. Um, this. Okay, I am doing this. I'm realizing that every time I Control C copy, it pauses my recording, which is a bit annoying. But I'm not too concerned. Because this isn't important anyway, so it doesn't matter that some of it's not going to get recorded, but that's just how it is. Okay, what I'm doing here is I'm removing the unknown solutions because I feel like that's confusing. Like I have it here, but I don't have it in the other ones. I don't know if I should. I'm gonna assume I don't because we don't know what they are, so that wouldn't make a whole lot of sense. But yeah. Task force, what was this? Oh, these are onto organic analysis now. So this should all be fine because we don't have any concentrations. This ammonia one needs to be hmm. Uh, this as well, I suppose. Okay. Should be everything. I don't think I have to include lime water because it's like not anything. I guess I should put it in as well anyway. I'm not going to include it. I don't think I need it. And then all I have to do now is change my references. So this one, this one, this one probably. Yeah, these are all fine. So I got 1, 2, 3, 4, 5 different ones. And then I just basically need to change at least 2 of these to be books um, instead of websites. Because basically when I did it at first, it was all I just did chem guide for all of them. Obviously, you can't just use the same reference for everything and get full marks, so that is precisely why I need to change them. So that is what I'm going to do. So I'm going to spend a little while researching that, and then I'll be back for when it's done, and then I will get onto whatever we have today. What is it? Kinetics II, which is a what do you call it? An AS topic, I think. So should be easier. AS topics generally are, and then carbonyls. Assuming we get through Kinetics 2 pretty quickly, um, carbonyls should be doable as well. Hopefully we get more than we got done yesterday. Yeah. Hopefully 60 minutes each will be enough. But we have 3 hours from now to get done, so not worried. Okay, I'll see you. Well, I guess mostly it'll be me watching this. I'll see me in a moment. Okay, so I found this now, which is a book which includes the test for alkenes, which is very good because I can include that in here. So now we have this page 148. We can go. I have a document here that basically just tells me how to reference. So let's go back to the start and we can see everything we need here. Published in 2018, I'm guessing. Yeah. So let's do that. So uh, Curtis C and Murgatroyd J. Was it something like that? The spelling? Murgatroyd. Yep. I think it's a comma and then like that. Then we have year of publication, so 2018. And then we have what am I looking at us here? Title. So Pearson at Excel International AS Level Chemistry. Course in full caps. And then what else was it? Am I looking at edition of later than first? I do not believe it was. No, since the first edition. So that seems okay. Place of publication, UK. London, but do we have to say that? I mean, let's look at our examples here. Great Britain, Ballum Bain Ltd. Okay, so It's just Pearson Education Limited. So there we go. There we go. That's done. Going to full stop. Yeah. Okay. I had a oops. Okay. Um. Okay. That's one. That's half. So now I gotta go and do another one, which I will do. So I will be back when I've done that. Okay, I should have this now done. So that's all the referencing I need to do. Believe the hazard tables are correct. I suppose I will find out. But that is everything I believe I have to do on this. So I should just be able to move on to some revision now. So I'll get this uploaded and then I'll get right into it. Okay, so I've decided what I'm going to do is instead of just reading through this, because as you can see, it's quite uh, lengthy. I'm going to go straight into the questions, and then I am going to refer back to the document in that manner. And I'm going to go based off of just what I already know from the topic. And then we'll get on to carbonyls, I believe it was. Okay, so question one. 4 sketch graphs are shown below, which would be a graph of the concentration of a reactant on the vertical axis against time for a zero order reaction. So the axis is very important here. concentration on the vertical axis against time. So it's it's the rate for a zero order reaction. So the rate for a zero order reaction would decrease because it just, yeah, wait, zero order reaction, because a zero order reaction means that increasing concentration has no effect on rate. So if it has no effect on rate, then rate will just then the concentration will just decrease as the reaction goes on. Wait, what am I saying? I think it's B. I don't know why though, because I've lost my train of logic there, but I'm gonna go with D, and I'm gonna immediately check the answers actually, because I'm not confident in it, and then I can kind of reason out why it's, what do I say, D or B? B I think is what I'm gonna go for. And then I can kind of like reason out. I mean, C just seems unrealistic for a zero order, but who knows? So I just have to open the mark scheme here. And then we can go through this. So the answer to 1A is B. So we got that right. So yeah, it decreases. Okay, 1B. I managed to not see the answers to the other ones, but should be able to get it anyway, which could be a graph of rate of reaction on the vertical axis against the concentration of a reactant. Rate of reaction over concentration for a first order reaction. I believe that would be D here. First order. Increasing concentration means an increase in rate. Makes logical sense. I would go with D. Question C. Which would be a graph of rate reaction on the vertical axis against square concentration for a second order reaction? Would assume A there. Because it's exponential. It's like double. It's for every one. It's like double this, right? So for every same increment in concentration is twice the um, effect on rate. So D, which could be a graph of the concentration of a reactant on the vertical axis against time for a reaction which is catalyzed by the product. I have no idea what that's saying. Let's read this again. Which could be a graph of the concentration of a reactant on the vertical axis against time for action which is catalyzed by a product. Hmm. Catalyzing reaction, does it have any effect on the graph? Doesn't change the concentration. It increases rate, so I suppose. Hmm. So maybe it could be C because there's an. I might go C just because it's the one we haven't done yet, but would not be sure. So now I'm gonna check the answers. B, D, D, C. Okay, so 1C we got wrong here. So let's look at that. So I went with A, which could be a graph of rate of reaction on the vertical axis against the square of the concentration. Oh, against the square. See, that's the difference. So it's just against the square of the concentration. Of course, it will be D there. That makes sense because it's already accounting for the exponential increase. So 3 out of 4 there. Let's go to question 2. 2. The rate of equation for the reaction is rate equals KRX. Which of these statements is correct? Rate is directly proportional to Rx. Rx is a primary halogenoalkane. The action mechanism is SN1. Carbocation intermediate forms in the reaction. Okay. Hmm. Um. RX is a primary allergen alkane. Does that make sense? To form an alcohol, I suppose. I don't see anything wrong with that. The action mechanism is SN1. Hmm. If it's primary, it should be SN3. What am I saying? SN2, sorry. Primary should be SN2. So maybe the answer to that is C. Well, it's going to be either C or B because they're contradictions, I think. Is the idea here? Um, but not super confident on that. Let's move on to question 3. The rate equation for the reaction between hydrogen gas and nitrogen monoxide gas is rate equals K NO2 NO squared H2. Concentrations of both reactants is doubled. The rate will be increased by a factor of 8. We're doubling, that gets us to 2. Then we double again because it's NO, that gets us to 4. Then we double again because it's second order, so it's 8. I would go D. A reaction has the rate equation rate equals x. Rate equals K x y squared z. The concentrations of each reaction is in the table below. If the rate of reaction under these conditions has a value of 0.24 moles per decimeter cubed, seconds to the minus 1, then the numerical value of K is. So we actually have to work this out. We do. Fun. Okay. So we should be doing rate divided by xyz basically. So let's do xyz first. 0.04 multiplied by 0.2 squared multiplied by 0.12. So that should be correct. Our answer there is 0.000192. And then we just do rate divided by that number. So where's the rate? 0.24. 1,250 is the number I get. Which would mean the value of K is 1,250, which would mean it's D. Is that not quite large? Not sure, but I don't know. It's one of the options, so. The units for the rate constant K are mole to minus 3 decimeter cubed. Okay, this should be not that bad. So mol dm cubed, and we have 4 instances of that. And then we have mol, so we have basically mol dm cubed to the second minus 1 over mol dm cubed. And then 3 more, so we cancel them. And then we invert the second to the minus 1. Or do we invert the, yeah, we invert the others, so it's mol dm to the minus 2, mol to the minus 2 dm 6 seconds to the minus 1. Um, Wait, but it's 3, my bad, so it's mol minus 3 dm 9, so that would be A. So 4B should be A, I think. I mean, the only two that are even possible are D and A, because mol and dm have to be opposite ways around, so, and A is kind of the obvious one you go with there. 5, let's move 5. Equation below shows the hydrolysis of a bromoalkane. Particular bromoalkane rate equation is rate equals K RBR. Bromoalkane RBR is most likely to be sorry, just drinking coffee. Interesting. For a particular bromoalkane, the rate equation is rate equals K RBR. The bromoalkane RBR is most likely to be what? Well, I mean, it can't be A. Oh no, it can be. Wait. Um. Hmm. I think this is one of the instances where I should refer back to the notes, because I am kind of not picking up on what is the idea here. So here are some reactions. Let's just read through this quickly. The nucleophilic substitution reaction of halogenoalkanes and hydroxide ions, so that's clearly come up here a few times. OH minus CBr. Then there's the transition state, and then is that the same one that came up yesterday? Like the exact same. That was in equilibrium. What was it we were doing yesterday? NMR, chirality. Pretty sure that was the exact same mechanism that showed up there, which is interesting. Forgot the context of why that exactly was there. Something to do with. Oh, it's. Okay, doesn't matter. CH3 CH2Br plus OH minus goes to CH3 CH2OH plus Br. Slow step. Rate equation is R equals K CH3 CH2Br OH. Makes enough sense. Reactants. This is called SN2. Blah blah. two molecules in the same step. Primary halogenomicons tend to react via the SN2 mechanism. Ooh, that's useful for the question we covered here too. So primary halogenoalkanes tend to react via the SN2. Oh, that's not useful because we already knew that. Okay, here. Oh, there's the bottom. Right, I can't scroll. SN1 nucleophilic substitution mechanisms for tertiary halogenoalkanes. Tertiary halogenoalkanes mechanism is a tertiary carbocation is stabilized by the electron releasing methyl groups around it. See alkenes, for an example of this. Also, the bulky methyl groups prevent the hydroxide ion from attacking the halogen-alkane the same way as the mechanism above. Okay, what are we looking at here? I don't understand how we figure this out. So what can we get from this that tells us? Oh, okay. Oh, okay, I see. So this is the only reactant. So we know it's SN1. So that's the first thing. So if we know it's SN1, that means it's going to be a tertiary haloalkane, and only one of these is going to be tertiary. That's what we're looking at here. So we actually did know, we just didn't think about it properly. So the only one that's a tertiary haloalkane here is, I'm guessing, D? Yes, because this is still primary, this is primary, this is primary, so it is D. D will be what we're going to go for there. Okay. Not as bad as I thought. Oh, 6. How many questions are there here? A lot of multiple choice questions. Wow. And then get about halfway and we get to the others. So 21 pages of Kinetics II questions. I don't know if we're going to get through all of them. We'll try and get through as many as we can. And cover as much content as we can by the time the video gets to an hour and 15 minutes. Or hour and 20 minutes. I'm pretty sure I spent like an extra 5 minutes after I paused the recording because I accidentally unpaused it. So there might have just be 5 minutes of silence. But hey ho. Um, and then, I mean, I've wasted a lot of time here because it's closing in. Well, we're 10:30 now, so hour and a half remaining. We're gonna probably go another half an hour on this, at least. So we're definitely going past midnight once we go on to the other one. And then I kind of want to grind some Sea of Thieves. But obviously I'm probably not going to record that unless I have some combat encounters. I might go for that actually. Okay, I'm going to take a short interval. I'll be back in 5 minutes. So I will resume then. So I'm just going to quickly pause my recording. I'll be back up. Okay, I'm now back and we're going to get on with question 6. Okay. Propanone reacts with iodine in an acidic solution as shown in the equation below. CH3, COCH3 aqueous plus iodine aqueous goes to form CH3, COCH2I aqueous plus hydrogen ions plus iodide ions. The right equation for the reaction is rate equals K, CH3COCH3 aqueous hydrogen ions, so just propanone aqueous and hydrogen ions. Okay, the most appropriate technique to investigate this rate of reaction is titrating samples of reaction mixture with acid. Ugh. Measurement of optical activity, measurement of the volume of gas given off, and color or colorimetry. Okay. Hmm. Yeah, I'm getting to a point where I'm so tired I'm struggling to think of what makes sense here. So optical activity doesn't make sense. Well, no, it doesn't make sense because both have a double bond on, like, there's no chiral carbons on any of them, so neither of them will be optically active. So we can exclude B, hydrating samples of reaction mixture with acid. Reaction mixture, so that's measurement of the volume of gas given off. That could. There's no gas given off. What? With the products aqueous. So I guess not C. Um, colorimetry. I'm gonna assume it's A. A makes the most sense, I think, even though I don't understand why it's A. I will have to investigate that. Um, maybe colorimetry works because of the iodine, right? Maybe and the iodide ions. Maybe it's D. I'm gonna go with D because I don't really understand what titrating samples of reaction mixed with acid would do because, like, are they do what happens if you react a ketone with an acid? I have no idea. Should I know? Maybe. Okay, yeah, 6A, 6B. I think we should go to 7B. Oh, this is. I think this is important. I think we just go to 6C and then go to 11. And then, and 12. And then probably go straight to 1. Here. I think that's what I'll go with. Okay, 6B now. Which statement about the reaction is not correct? The overall order of reaction is second order. So that would mean that there was two. Does overall order of reaction mean the rate determining step is second order? Or does it mean that there's two first order reactions, so it's overall second order? Um, well, I think it is overall second order, so I think A is fine. I think the units of the rate constant are dm cubed moles on seconds to minus 1. Does that make sense? No, that does not make sense. Oh, wait a minute. Yeah, that doesn't make any sense. What? Why is the 3 and the 1 the wrong way round? Also, well, it's got to be B because it's just wrong. It should be dm minus 1 moles cubed. Pretty sure. So I'm gonna go with B there, and then 6C. Hopefully we get something a bit quicker. The reaction is carried out using a large excess of both propanone and acid, which of the graph below shows the change of iodine concentration with time. What's... Wait, so the rate equation is this. Why is it H plus ions? Oh, in acidic solution, that's why it's H plus ions. Why is the iodine excluded again? Because iodine's not participating in the reaction. Not sure. Change of iodine concentration with time. Well, it'll decrease over time. Maybe in a linear fashion, because it's first order with respect to both things, so A is my guess. Okay, that's how we do that, and then we should just mark this. It could be C actually here. That makes more sense actually, C. Yeah, okay. Let's take the answers. So 2 is B and we had C. So let's go back to 2 and look at this. So the answer was, correct answer was B. Rx is a primary halogenoalkane. Well, we figured it was going to be one of them, didn't we? So the reaction mechanism is SN1, but Rx is a tertiary halogenoalkane. So how do I know that? How would I figure that out? Hmm. Oh, because we know. Oh, the reaction, the equation is K equals Rx, so we know it's a SN1. So we know it is SN1, so Rx has to be tertiary. Yes, that's quite simple to be honest. I could have got that, but oh well. Okay. Next answer is D, which we got correct. Answer after that is also D. Answer after that is A. 1250. We got that one. Answer to question 5 is D again. We got that right. Answer 6A is D again. We got that right. Answer 6B is D again. So we got that wrong. So 6B. Let's have a look at that. 6B. Measurement of optical activity. Oh, that's 6A. 6B. The units of the rate constant are... That's what? 6B, the answer is D. The rate increases 4 times. That makes sense though, because when you double it, the whole, with respect to the whole reaction is second order, so when you double what? The rate increases 4 times when the concentration of propanone and iodine are both doubled. Hmm? Because when you double one, it doubles, and then when you double the other, it doubles again. That's 4 times. Oh, it means it increases 4 times, not by 4 times. No, no, it definitely means by 4 times. What? This is not making sense to me. Why it's not B? Why is it DM3 more to the -1? Oh, it's reversed. It's they've just done it the reverse way round, but it's still correct technically. Yeah, it's mol to the -1 DM3, but they've done it the other way around. Wow, that's funny. Okay, so that is wrong. I still don't understand why D is wrong. Why didn't it increase 4 times? Well, I understand why B's correct. And then C, the answer should have been C, which is not what I got. Its answer should have been A, sorry, and I got C. It's what I had initially. I can completely understand why that's. I mean, I know, yeah, yeah, logically that makes sense. Yeah. Okay, well, let's move on. And so out of the last 1, 2, 3, 4, 5, 6, 7, 8, we got 5. So 5 out of 8 there. And then we can move on a bit. So question 11 was what I was going to move to. So question 11 here. Which of the following changes will lead to the greatest increase in the rate of the following endothermic reaction? Hmm. I just had a thought. It's getting quite late, and obviously we haven't got onto carbonyls yet. So what I might do is wake up early tomorrow and do carbonyls, and then um, I'll be busy for the day, but I'll do carbonyls in the morning, early morning, and then I will do all the normal stuff in the afternoon. I think that's the what I'm gonna go for. Yeah. Okay. Okay, let's get on with these. Get at least to a point where we're happy with what we got done. So, which of the following changes will lead to the greatest increase in the rate of the following endothermic reaction? Temperature, initial concentration of nitrogen and oxygen, decrease. So, which of the following changes will lead to the greatest increase in the rate of the following endothermic reaction? Well, obviously you want an increase in temperature, so it's going to be BOD, and an increase in initial concentration as well. What am I missing here? Maybe. Hmm. Why isn't it D? That's my question. The forward reaction, which is the only reaction because it's not in equilibrium, is exothermic. That doesn't. Hmm. I don't know why I wouldn't assume D here. I suppose we'll find out. 12. The Maxwell-Boltzmann distribution of molecular energies is used for explaining why increasing temperature affects the rate of a chemical reaction. Which of the following statements describes how the shape of a Maxwell-Boltzmann distribution curve changes as temperature increases? Okay, this one should be pretty okay because I think I am quite confident on the Maxwell-Boltzmann distribution stuff. Okay, um, as temperature increases, peak in height decreases and moves to the right, I believe. So it should be C. The main reason that reaction rates increase with temperature is that all of the molecules move faster. Main reason that reaction rates increase with temperature is that all the molecules collide more frequently, more molecules collide with the correct orientation. So it's not C. Maybe it's B. This is a knowable thing that I don't know. This is just something I think you just have to learn. I'm going to say B here. Do we have any more? No. Okay, we have 13, so I suppose I should just do 13 because it's the last one in this section. 13A. Methods for investigating reaction rates include colorimetry, measurement, change in volume, measurement, change in mass, quenching. Okay, this is going to be bad for me. Oh, which method would be most suitable to investigate the rate of the following reactions? HCO, CH3. Plus sodium hydroxide. Mm, hmm. Maybe this is quenching followed by titrating with acid. Change of mass wouldn't be good for this. Change in volume wouldn't be good for this. Colorimetry is the only other one that makes sense. Maybe. What color is... What's that? Ethanoic acid. What color is ethanoic acid? Probably colorless. Sodium hydroxide is definitely colorless. What color is HCONA? I'm going to go with D. Question B. Uh, hmm. What's that? Methyl propene or something? No. Yeah, methyl propene. Plus hydrogen iodide. Maybe measurement and change in volume. Wait, what? Yeah. I mean, it's all gas, so that would make sense. C. Uh, Brom BrO3 minus aqueous plus H plus. Uh, this one I feel like is the colorimetry, so I'm gonna go with A. These are all just kind of intuitive. I don't actually know the answers. Okay, let's check out the answers. So looking from 11 down. Here we go. 11 is D. Got that one correct. 12A is C. 12B is D, so we got that one wrong. 12A is D, 12B is B, and 12C is A. All of them are correct. All of 13 is correct. That's surprising, But I think maybe my reasoning for these is sound. So this one, process of elimination, basically, the others make sense. This one, they're a gas, change of volume makes sense, and this one, the bromine is very colorful. So brown liquid, we would see a color change from with the bromine ions, I suppose. With the colorimetry, makes sense. Okay, so let's check out 12b there. The main reason the reaction rates increase with temperature is that all the molecules move faster. So what was the correct answer there? Uh, D was the correct answer. So the answer was a large proportion of molecules have high energies. Yeah, I mean, it makes sense. It's just the main reason because the others are all like valid reasons. Well, C isn't, but A and B are technically also correct, but they're not the main reason. So it's just something you have to know, I guess. And I didn't know it. So now I know that the main reason that reaction rates increase with temperature is that a large proportion of molecules have high energies. That is something I can just keep in my brain, I suppose. Okay. Let's move on to question one. This is a very long. So, some calculations here and graphs. So the graph stuff is kind of graph one over time. Yeah, so these are just like order of reaction graphs. There's another one up here, was there? Yeah, so this one's also order of reaction, I'm assuming. Yep. So I will not answer the graph ones because obviously it's going to be a bit difficult. I mean, I could go into paint again, but not ecstatic. I'm not jumping at the idea of doing that. So also, is my audio? Hello. Oh, is that louder? Like, what is this decibel thing? I may have had the wrong audio settings on for the whole time. uh, okay, well, glad to know that that was there at least. Anyway, back to the question. Let's start on question one. We've got a one marker to start off. Hopefully it won't be too bad. This is a question about how clock reactions are used to study reaction kinetics. The bromine clock involves, oh no, not these halogen clock things. Involves a reaction between bromide ions and bromate 5 ions. You know what I want to look at? I want to go into our summary notes and look at the quenching stuff. Uh, Cooking activation from I haven't looked at this a lot. Maybe we'll have to go over that next time, but cover this topic. But working out orders when two reaction concentrations are changed simultaneously. Most reaction. Didn't I want to do biology as well? Okay. Where is our quenching? Yeah, here. Titrating samples of a reaction mixture with acid, alkali, sulfate, etc. So that is basically what the iodine and stuff is. I think this is the iodine clock here. The iodine can be treated with sodium sulfate. Small samples are removed from the reaction mixture, quenched, which stops the reaction, and then titrated with a suitable reagent. How does that tell us the rate? I suppose it tells us the moles. Might have to watch like an explanation on that just to be thorough. I mean, I get the concept, but just the specifics of that are not something I'm thoroughly familiar with. Um, this I haven't seen much about measuring change in electrical conductivity, but this is very interesting. That one. Um, that makes a lot of sense as well. I feel like it's very applicable as well, right? Anyway, give me a quick look at these. I mean, it's pretty much familiar with rate concentration graphs. I know these, but the concentration time graphs, these ones here are um, less known to me. But that's something we'll look at another time. We will get on with question one because we are 1 hour 6 minutes into the recording, so got to be it's getting close to midnight now. 11:55, so should be finishing up within the next 10 minutes or so. So 10 minutes of questions, or I suppose more like probably 5 minutes, and then 5 minutes of review. But okay, it is assumed the initial rate of reaction is proportional to 1 over time taken for the methyl orange to be bleached. Explain why is it essential for the amount of phenol to be small compared to the amounts of reactants for this assumption to be valid. Okay, I need to read this again because phenol and methyl orange are added to the reaction mixture. So what does the phenol do? In order to monitor this reaction, the phenol and methyl orange are added to the reaction. So it's becoming less acidic, so that's why the methyl orange is there. I understand that. Um, a small fixed amount of phenol is present, which reacts immediately with the bromine as it's produced, thus removing it from the. Oh, I understand. Okay. So it's something to do with the color change of the bromine. Oh, so the color change of the bromine would mess up the methyl orange. So it has to remove the bromine color. Oh, I see. It will bleach them. Okay, well, it just explains it there. Is assumed that the initial rate of reaction is proportional to 1 over time taken for the methyl orange to be bleached. Explain why it's essential for the amount of phenol to be small compared to the amounts of the reactants for the assumption to be valid. Um, well, I kind of get what it's going for. Like, it can't immediately react with the bromine, otherwise there'll never be a color change. It only needs to be enough to react with the the bromine produced initially. That's what I'll put. Only enough phenol to react with the initial bromine produced. I'm pretty confident that that is the wrong answer, but I'm getting in there anyway. Okay, a series of experiments was carried out where only the concentration of bromide ions present was varied and the solution contained a large excess of Br minus and H+. The total volume of the mixture is kept constant. Why is it important that the solution contain a large excess of BrO3 and H plus ions? So, so the like I know the answer, but I just don't know how to explain it. Like the it's so the the bromide ions are limiting. Like so the I'm gonna just write that like so the bromide ions are limiting. Or so the bromide ions determine the rate of reaction. Yeah, that's better. Okay, okay, I can't do that. Not do that. BIV. The reaction is first order with respect to bromate 5 ions and second order with respect to hydrogen ions. Write the overall rate equation for the bromine clock reaction and deduce the units of the rate constant. Okay, let's check it out here. So it includes all three, I'm pretty sure. But I can't do this, I don't know the order. Okay, we're gonna have to skip that one as well. Oh. Yeah, we don't know this, so. Okay, well we have data, so. Does that look? Looks pretty first ordery to me. I'll go first order, so then that would mean that the equation is rate equals K. Concentration of Br minus concentration of BrO3 minus concentration of H plus squared. And then the units of the rate constant are just going to be moles minus 3 dm9 seconds minus 1. Okay, what are we on? 114. Ugh. Main reaction is H2O2, aqueous. Disulfide ions present immediately with iodine as it is produced as a solution. Hmm. Why are the potassium ions omitted from the above equation? They don't take part in the reaction. They are not oxidized or reduced. Maybe that's the answer. CI. They are not oxidized or reduced. CII. See the observation made after also values more iodine is produced. Is there starch in here? Yeah. I didn't really read it through properly, but assuming there's starch here and iodine is produced, presumably that means the solution is going to go blue-black. Okay, let's check the answers and then I think we should be done. Okay, question 1A. So that the phenol is used up before the rate changes. Only enough phenol to react with the initial bromine produced is needed. I don't think we get the mark. I mean, it's closest to that second point. So the phenol is used up, methyl is produced during the initial rate period. But I haven't said during the initial rate period, I said when the initial bromine is produced. So I think we lose the mark there, unfortunately. So that's 0 out of 1. BI, concentration of bromide varies during the course of the reaction, so the concentration of bromide is a limiting factor. That's pretty much what I put. That is what I put, so that's 1 mark. BIV is the next one we answered. This one's pretty easy to determine whether we're right. Rate equation is correct there. So that's 1, and then the units are correct as well. So that's 2 for 2 there. And then CI, they are not oxidized or reduced is what I put. That's basically what I said, isn't it? Yep, that's pretty much it. I'm gonna give myself the mark for that. Position goes blue black. Yep. Okay, so 1 out of 1 there. So we lost only 1 mark in that section. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 marks available there. So if we switch to our other window, 18 marks available, and we scored 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 9, 10, 11, 12, 13. 13 out of 18. So if I'm correct, we dropped 1, 2, 3, 4, 5, 6 marks. What? Doesn't make sense. We dropped 6 marks, but this says we dropped 5, so maybe I added up wrong. That's 8, 9, 10, 11, 12, 13. So it's out of 19. 1, 2, 3, 4, 5, 6. And then, yeah, it's out of 9. No, what? 6 plus 8 plus 4. 18. But we dropped 6 marks. Oh, it's 3 out of 5 and I've forgotten to include something, haven't I? Ah, I haven't marked a whole section. So, here we go. And then this one we scored 1, 2, 3, 4, 5 out of 6. That's why it's not making sense. Okay, so 10, 18, 19, 20, 21, 22, 20, 24 marks available. And we scored 8, 13, 14, 15, 16, 17, 18. 18 out of 24. Which makes sense how we dropped 6. 18 out of 24 as a percentage is 75%, I think. Yes, 75%. Not terrible. And we'll go green for this because we have done certainly a decent amount. We have done 65 minutes of work. And then what I'm going to do is we're going to do this tomorrow morning. Let's do some GeoGuessr. Okay. Community maps. Okay. Is that the road? Is this a repeat or? Because there was that one road I got in New Brunswick, was it? Oh no, it wasn't New Brunswick, it was Newfoundland, wasn't it? It was, or was it up here? Oh shoot. I've forgotten this, I think it was up here. Except there's no roads here. Okay, so it probably was the other, unless it was this. Wait, what's the angle? Northeast? Was it this? It was either this or like here. But okay, it was not a repeat, so okay. I don't recognize that sign. Kind of looks like Scotland. Sun is south, so it's not some like crazy some crazy Argentina or Chile more. However, I would probably go Scotland here. That looks like an English gate. The rocks make sense. The soil definitely makes sense, like the color as well. So, and we got like a Western Sea. So, Wick. Or even could it be like on the Shetland? Yeah, maybe Shetland makes more sense. Nah, Shetland doesn't look like this. It would be here somewhere. I'll go Wick. I'm tripping. I said Western Sea and I clicked on where the sea is east. This is atrocious. I mean, come on. What are we doing here, guys? Another small cam. Mm, it looks like Russia. But also it doesn't look like Russia. Like, what are these little flowers? I'm just gonna go like North Russia. Maybe up here or something. It's Finland. Yeah, that makes a lot of sense. Okay, not getting much on this one either. Probably shouldn't be playing at 1 a.m. Well, it's not even 1 a.m. It's just midnight, but whatever. Like northern West Australia. I don't know. Could be northern as well. Maybe it's more south. It makes sense to me. And it's New South Wales. Yes. Okay, well, this is surely Ireland. I don't really know the meta for Ireland, but there's no car, so yeah, this just looks like Ireland, bro. I don't know. Wrong place. Like over here. Could be Northern Ireland as well, but it was Scotland. Okay, well. Kind of disappointed with the score. Maybe I'll have to go again. Is another UK? It is. This is Ireland. Like I'm telling you, this is Ireland. No way, it's not. Oh my God, it's the UK. It's craziness. This Colo. Mm. Gotta be Colo. That was left-hand drive. I thought it was right-hand drive. I'm too tired for this. Pole isn't telling me a whole lot. Is it Mexico? Where's the sun? North, so it's not Mexico. What? Sun's north? Where is this? Has to be like Chile then, right? Where else looks like this? What? No, I'm tripping. What? Nowhere looks like this. Is it Colombia, possibly? No, can't be Colombia. What? I don't know. It's not Brazil, right? No way. The poles are wrong. Fence doesn't look that south. Maybe we go Peru and pray. It was Argentina. Oh, this score doesn't look like it's gonna get a whole lot better, does it? We in India here. Does this not look like up here? Punjab? Yeah, it doesn't. I don't know. Colorado. Yeah, that was a terrible score. 12k. Only getting worse. Okay, well, we'll go for one more because can't end on that. Southern Sea. What makes sense here? Curving coastal road. Very hilly, basically that's the whole south coast. Is it divided? No, so it's not there. Just go some random little place. Okay, it was Alanya, but whatever. Uh, hmm. Tocantins, Goyas, I don't know. What's Tocantins? Is this one Mexico? What is that? What's a plant? I don't even. It's probably US, isn't it? Yeah. Where? Your guess is as good as mine. Texas. New Mexico, I guess. Score's looking a little bit healthier at least. Until we get this round and I go wrong continent. Because it looks like Taiwan. There's no way this is Taiwan. Let's look at the road. Road doesn't really help me. Wait, that's not a Taiwanese sign, right? Where is this, bro? Could be Norway. Probably, like, I don't know. I got no clue here. Polish looks more European. Maybe I'll go Norway. Scotland? Seriously? Well, 3,000 points on a round that I was pretty confident I was going to send wrong continent on is pretty fine. 9. Wait, why am I blanking? What are the road lines? What is that mountain? Yo. Oh, it's southern. So it's gonna be down here or like here, and I don't know which. Well, there's huge mountains to our south, so but there's not huge mountains this way, so oh, it's east in fact, so maybe it's more over here. I don't know. Puerto Cadernas. It's a bit small. Looks pretty built up. Road angle is west, which is weird as well. Probably in a decently sized town here. Yeah, this could work. Let's go here. And it was basically Santiago. Well, 17.5k is far better than what we just got, so I suppose I should take that. Okay, that'll be all for today. We'll get our carbonars done tomorrow morning. And yeah, that's all. Good night.